All right, we're going to try it again to talk about an angle in standard position such that the terminal side passes through a specific point. Here in this first problem, we needed to pass through the point 6, 2, which means it's got to be in quadrant 1. My angle that I map out is in quadrant 1. If I was so inclined, I could build my trig ratios. I would have to calculate the hypotenuse, but the tangent would be easily arrived at by using the side adjacent or the side opposite over the side adjacent. If I look at the next one, I need to go through the point -4, 3, which means now I'm going to have an angle that maps into the second quadrant. Again, I could bring down that perpendicular and put in an angle in that right triangle and calculate my 6 trig ratios. So if we want to make this generic for what we just did, we're going to take our terminal side of our angle and pass it through a generic point called x, y. Drop a perpendicular to the x-axis and create a right triangle and develop our 6 trig ratios. So the sine of my angle is the side opposite over my hypotenuse. The cosine of that angle is the side adjacent over that hypotenuse, which is the radius of what I'm sweeping out. And the tangent of my angle is the side opposite over the side adjacent. And then we get our other 3 ratios just by taking the reciprocal. And we need to keep in mind that the r has to be positive, or else I'm not going to be sweeping out any angle whatsoever. And now we can create this generic case here where we take our x, y, which is positive, reflect it over the y-axis to get into quadrant 2, and we notice what changes is the x-coordinate sign, not the y-coordinate. And then when I do a subsequent reflection to get into quadrant 3, it is the y-coordinates sign, S-I-G-N, that changes. And then finally, when I reflect back in the y-axis to get into quadrant 4, it is the x-coordinate that changes, S-I-G-N sign, and becomes positive again. Based on that information and how we construct our sine, cosine, and tangent ratios, we can come up with some rules that the sine function is going to be positive in quadrants 1 and 2 because our y-coordinate is positive. And our cosine function is going to be positive in quadrants 1 and 4 because our x-coordinate is positive there. It's the x and y's sign that drives the sign of the ratio, because the radius is always positive. And then our tangent is positive in quadrants 1 and 3 because those are the quadrants in which the SIGN sign of both the x and the y coordinate match. Now these next two problems, we just have to take it a piece at a time and determine in which quadrant both of the conditions are satisfied. So I would start with in which quadrant is the sine of theta positive. The y-coordinate's positive in quadrants 1 and 2. And then it says the secant also has to be negative, which means the cosine has to be negative. And that's not true in quadrant 1, but it is true for quadrant 2. The next one says in which quadrant are both tangent and cosecant, which is the reciprocal of the sine, both negative. So I start with tangent being negative in quadrants 2 and 4, but then selecting quadrants 4 because that's the quadrant in which the sine ratio, hence the cosecant ratio, will be negative. The last two problems, we're going to draw the triangle given the information about the specific trig ratios. So we start with the information about the secant, and we translate that into information about the cosine. And we notice the cosine is positive. So I'm thinking we're talking about something, an angle that's in quadrant 1 or quadrant 4. Then I use the second piece of information, the tangent ratio, which is negative, And at this point, that happens in quadrant 4, so I know I have to map my angle into quadrant 4. Then I use the information about these two ratios to label my triangle. And the cosine is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. And then I create my other 4 ratios. The sine is opposite over hypotenuse, keeping in mind that I have to make sure that I use the negative here for the 5. And I take the reciprocal. And the tangent is opposite over adjacent, which they gave us, so I just do the reciprocal to get the cotangent ratio. The last little one here, we've got information about the cotangent being positive. So I'm thinking 1 and 4. The cotangent of 2 gives me a tangent of 1 over 2. But then it does tell me we're not in quadrant 1. We have to be in quadrant 3 because of that extra information. And I construct my triangle, opposite over adjacent, both having to be negative. I have to do some Pythagorean to get the length of my radius or hypotenuse. And then I create my cosine ratio, adjacent over hypotenuse, and take the reciprocal. I create my sine ratio, opposite over hypotenuse, and then take the reciprocal. You want to make sure that you put the negative either to the numerator or out front of the entire ratio.